We are going to start topic 8, section 2. Last week we did special right triangles, 30, 60, 90, 45, 45, 90, correct? And we worked all week remembering and using those ratios, and they're not going to go away. You're still going to use them. We're going to combine them to our sine, cosine, and tangent. They're the trig ratios. Sine, we abbreviate sine. Let me zoom in a little bit here. We abbreviate sine just to SIN. And there should be an angle. I use this from another thing. So we'll abbreviate it SIN, and we're going to use theta for our symbol for an angle. Theta is a really common use that they. Circle with a line? Yep, it's a circle with a line through it. We could just call that theta. Devin, can you take your hood off, please? Thank you. And so sine is opposite leg over the hypotenuse. And I'm abbreviating hypotenuse. And when I say opposite leg, it's opposite of the angle we're talking about. We also will say sometimes we'll just put O over H. What's O stand for?
Opposite leg.
Opposite leg. What's H stand for?
Hypotenuse.
Hypotenuse. Okay, so coming down to this right triangle right here, we're going to label it real quick. The side opposite angle A is side A, isn't it? So we put a lowercase a. And AC is opposite angle B, so it's side what? B. And they're lowercase because they're sides. Angles are uppercase, sides are lowercase. And C is the hypotenuse, always across from the right angle, is a lowercase c. So using this triangle right here, we're going to answer the questions over here. It says sine of A. So these both go to this triangle right here. So sine of A, so here's A. Well, the leg opposite of angle A is leg what?
B. Well, A.
A. And the hypotenuse is C.
B.
Well, we're going to do B. So B is down here. I don't even know if that shows up as a different color on that screen. But B is down here, so the leg opposite angle B is leg what? B. And the hypotenuse is what? C. So that's just basically how it goes. So we're going to use the two triangles we're given. So sine of A, well, here's A. Opposite side of A is 3. And the hypotenuse is what? 5. Now, the hypotenuse is a hypotenuse, correct? It's nothing else. It's not a leg. It's not an opposite. Right? We're going to have adjacent here in a minute. It's not adjacent either. Okay, so then I'm going to go to B.
4, 5.
So angle B is right here. So opposite of angle B is 4. The hypotenuse is 5. So it's 4 over 5. And these are a fraction, guys. It's a ratio. It's 4 to 5. It's 4/5. Okay, do sine of A and B on the next triangle on your own. Okay, opposite of A is 15. And the hypotenuse is 17. Hypotenuse should always be the bigger, right?
Okay.
And then opposite of B is 8. And the hypotenuse is 17.
Are we always going to get those the numbers?
Nope. Not always. In your assignment today, I think you will. But there's times they could give you 2 of them, right? And you could solve for the other one with Pythagorean theorem. Or you could solve for the other one if it's a 30, 60, 90, 45, 45, 90. You could figure those out. So there's different things. Tomorrow we'll solve for an angle. And sometimes they give you an angle and a side, and you can solve the other sides for that. So we'll be doing all sorts of things with them. Okay, next is cosine. And we abbreviate cosine COS. So the cosine of theta is equal to the adjacent leg over the hypotenuse. So guess what we abbreviate that as? A over H. And A stands for adjacent leg, H stands for hypotenuse. Okay, so help me label this. Triangle over here with A, B's, and C's. What would I label the side AC as?
B.
B. And what would C be?
A.
A. What would BC be? That's weird. And AB?
C.
C. Okay, so again, we're going to do these over here. So cosine of A, so here's A. And adjacent means touching. Okay? What leg is touching A?
B.
B.
B over C.
B over C, because the hypotenuse. Now, somebody last hour said, well, what about C? Isn't that touching it? Well, C is the hypotenuse, right? It's not a leg.
From the 90-degree angle.
Yep. C is the hypotenuse. It's not a leg, so it doesn't fit that. Okay, so B is here. So what's touching B? A.
C.
So A over C. Now, do you notice that? Oh, no. Never mind. Okay, cosine of A.
16 over 34.
So it'd be 16 over 34. Can I leave it 16 over 34?
You should probably reduce it.
It probably should. How about to 8 over 17? And then B,
30 over 34.
30 over 34. Melissa's got this. She's going kind of fast. Is everyone good?
Yes.
Okay.
I think this is like the first actually geometry assignment that I've actually done. Besides the side angle side and the side.
So wait, how is cosine different from sine if it's just one of the legs in the hypotenuse?
Well, it's the leg, the relation you're talking about, because sine is the opposite leg and cosine is the adjacent leg. So sine is the leg opposite of the angle, and cosine is the leg that is touching the angle. Okay, now, do you guys know a shortcut? Not a shortcut, but a way that makes it a little easier. If I look at a triangle and I see, do you guys see that 16, 34, and 30 are reduced? Like I can reduce them by 4, can't I? So if I can, not by 4, by 2. So if I did that, this would be 8, this would be 17, and this would be 15.
Wait, what did you do to divide them by?
I just 2. I noticed 2 went into all of them. And when I did that, I wouldn't have had to reduce, would I? Because I did it at the beginning. If you do the biggest thing that goes into all of them, like 4 or 5 or whatever. Okay? Okay. You do the next one on your own. Jackson, what is the cosine of angle A? What leg is touching angle A? 7. And what's the hypotenuse?
24.
Hypotenuse is across from the right angle.
Yeah, it's 25.
So it's 25. Hypotenuse is always the bigger one too, isn't it? Xander, what is the cosine of B?
24 over 25.
24 over 25. Okay, tangent. You guys ready for it? Excited?
We didn't do it now.
Okay. Tangent of theta. Yes? Okay, tangent of theta, I'll get there, is opposite leg over adjacent leg. Guess how we abbreviate it? Over 8. So label your triangle here. You guys helped me on the last one, so now you get to do it.
Would this be the same?
Yep. So we should have B, A, C. And again, these are going to come over here. So the tangent of A is
A or O.
Yep.
That's
A over
B.
B. And the tangent of B is
B over A.
B over A. What are the relationships between those two?
The flip.
What's the math flip?
Ratio.
Close.
It starts with the R, doesn't it?
It does. Reciprocal. Okay?
Why did I say ratio?
Because it started with an R. Okay, so they're reciprocals of each other. Well, they're reciprocals of each other because one is the opposite and one is the adjacent of each other, correct? Okay, so what could I do with all these sides? There's your warning, Missy.
Simplify. Not bad.
By what?
All by 5.
By 5. So I get 3,
5.
5,
4.
and 4. They all have to reduce by the same number, right? You can't do different numbers. That's silly.
What?
Okay, A.
15. Oh, 3 over 4.
No, 4 over 3.
Opposite,
Ah, okay.
4 over 3.
And then 3 over 4.
And then B would be 3 over 4. Should these always be the reciprocals of each other if you're doing them side by side? Yep. Okay, so do the next one on your own. You should have gotten 21 over 20 for A
Yeah,
and 20 over 21. So you are going to be using those today. And I would suggest that every time you do like sine of A, you write opposite over hypotenuse over H. So I can remember them, right? Now, has anybody ever heard somebody say, well, just use SOHCAHTOA?
No.
Nope, never heard it? You will. You hear it all the time.
Say that all the time.
Your brother said it to you yesterday, right?
Totally.
Okay, so what do you think SOHCAHTOA stands for? S stands for sine.
Sine.
Sine is opposite over hypotenuse. C stands for
Cosine.
is,
Adjacent over hypotenuse.
and T,
Tangent over tangent over.
right, opposite over adjacent. So if you remember SOHCAHTOA, can you do that? Can you remember it? Okay, we are going to go over the steps tomorrow to solve with because we're not doing that today. So we'll finish that tomorrow. But we're going to come down here, and I'm going to tell you, you might run into your work over here, but if you do them, make nice triangles. Okay, so we have 30, 45, 60, and 90, and they want sine, cosine, and tangent. So we probably need, what, 2 special triangles?
A right triangle.
30, 60, 90, and 45, 45, 90, and yes, they are both right. So we did those last week, yes? So we need a 30, 60, 90, and a 45, 45, 90, right?
Yep.
Draw yourself one of each. Okay, so you got one of each. Now we need to put our ratios on there. What was the ratio across from 30? A. What was across from 60? A square root of 3. And what was across from 2A? I can't talk evidently. So hopefully most of you remembered that. Okay, now I got 45, 45, 90. So across from the 45s is A and square root of 2. We're going to use this one so we have that 90 being the same. If you want to use the other one, you're more than welcome to. But I don't think it's any easier in this case. So now I have my two triangles, right? So I'm ready to go, aren't I? So I have the sine of 30. I'm going to do the sine of 30, cosine of 30, and the tangent of 30. I don't know why I spread them out so much. I feel like I just did exactly the same. Anyway. Okay, so I'm going to write over here what is sine, what over what?
Opposite legal one.
Opposite over hypotenuse.
So A
Okay, so A over
2A.
2A. Well, A over 2A, the A's reduced to 1, don't they?
Yeah.
So I just get
2.
1
Oh.
over 2. What's going to happen in the case of every single one of these A's, guys? Are they going to reduce
Yeah.
every time?
Yeah.
They're going to reduce to 1, aren't they? So can I just say that A equals 1?
You wrote.
I know. Bless you. Then I go tangent. Does everyone see how I can just say that it is 1? Because every time when I make these ratios, those A's are going to reduce, aren't they? So now if I just say, remember, A is 1, I don't even have to write the A anymore, do I? Okay, so cosine of 30. So 30 is adjacent over hypotenuse, so that'd be square root of 3 over 2. Just put 2 because the A's reduce out.
Yeah.
And now I know why I hadn't spread out so much. And the tangent of 30. Oh, we didn't write what cosine was. Cosine was adjacent over hypotenuse, right? What's tangent?
It's
A over-
A over O. Oh no, O over A. Over A. You were right. Opposite over adjacent. So opposite of 30 is 1. And then 1 over the square root of 3. And we learned last week we can't leave that square root of 3 there, can we? No, we got to multiply both by the square root of 3, right? So that would be the square root of 3 over the square root of 9, which is
It's one column.
3. So I have the square root of 3 over 3. Because 1 times the square root of 3 is the square root of 3, right? And the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So I got those, right? And so let's do the sine of 60.
Are we gonna have enough room?
You're going to have to use down here. We might. We'll see.
We still have to do 90.
You're fine. Yeah, we'll get there. Okay, 60. So opposite 60 is A squared of 3. But all of our A's are just what now? Just 1. So it'd be square root of 3 over what? What's the hypotenuse? 2. 2a, and a is 1, so it's just 2. And then the cosine of 60. Adjacent to 60 is 1. 1 over 2. And the tangent of 60. So just square root of 3 over 1. So it's just the square root of 3. Now, I would like you guys to look at what we got for the sine and cosine of 30 and 60.
So
See?
the sine is the same as the cosine.
But what's the relationship between 30 and 60?
It's just half.
Well, think about in relationship to a triangle, like the actual angles. What are 30 and 60 degrees? What's the relationship? Or 10 and 20? Not 10. 70 and 20. Or 50 and 40.
Oh, they equal 90.
They equal 90. They're complementary, correct?
Mm-hmm.
Okay, sine and cosine. They're co-functions, meaning that complementary angles are equal. So, the sine of 30 will always be equal to the cosine of 60. The cosine of 70 will always be equal to the sine of 20. Every single time, no matter what. Okay, so we need 45, right? So sine of 45,
Do we not do 90?
we will.
Oh.
I was
Oh,
just
we
doing them
just-
in order.
Okay, I see. And then for 90, since we have two 90s, we
Yeah,
just
we
do
only
that
have to do it
once.
once.
Okay.
Yeah. Okay, so 45. So opposite of 45 is what? Are my 2's going to reduce out again here?
Yeah.
Yeah. So opposite of 45. Oh, you're going, which 45? Does it matter?
No. they're
No.
the same.
So we'll do this top one. So opposite of 45 is square root of 2. Hypotenuse is 2. Now, Savannah, if you used yours, you had to rationalize. Okay, well, 45 and 45 are complementary to each other, yes?
Yeah.
So the sine and cosine of 45 should be the same, but we'll check it out. So here's 45. Adjacent to it is what?
It's going to be square root of 2 over
Square root of 2, but in the a is reduced. So square root of 2 over,
Square root of 2.
no, square root of 2 over 2. Hypotenuse. So they're the same, right? And they should have been. And then the tangent of 45. Well, the tangent is opposite over adjacent. Well, that's the square root of 2 over the square root of 2, which is just what? 1. Now we'll do 90. You'll have to do 90 probably down here. Sorry. So 90. Sine of 90. Which triangle you want to use? Does it matter? No. So opposite 90 is what?
Oh,
Wait a second. What's the opposite of 90? 2a. Okay. What's the hypotenuse?
2a.
2a.
Wait, is it just...
So
it's
Is it
just
going to be
one.
1
It's just
every
1.
time? Is it going to be 1 almost every time?
no.
Oh.
Cosine of 90. Um,
2a.
is there an adjacent to 90?
It's one of the a... No.
There's not an adjacent.
So would it be...
So we're going to put 0. And what's the hypotenuse? 2?
2a. Or 2.
2. And so 0 over 2 is just
0.
0. Now, tangent, I'm going to do a little bit different. Just because I don't like doing the other. So, what we noticed, like the tangent was the reciprocal here, yes? See that? And what do you notice about sine, cosine, and tangent? What would happen if I took this divided by this? Would I get this?
Yep.
Yeah. So if I take those things divided by, I can get it.
Yep.
So I have 1 over 0,
But that's undefined.
which is undefined. Okay, so sine of A, cosine of A, and tangent of A?
We would do this like 3 each number.
No, we're just doing it this so I don't have to, keep, like giving you different examples. So I just put it all in one. Okay, and then we're going to have cosine of, sine of B, right?
Mm-hmm.
But your assignment isn't that. Cosine of B and tangent of B. If your assignment does that, it usually asks you that's like 3 different problems or something like that. Okay, so A, we're looking at A, right?
Yes.
So sine is opposite over hypotenuse. So I get what over what?
5 over square root of 34.
5 over the square root of 34, but I can't leave it like that.
5 square root of 34 over 34.
5 square root of 34 over 34. And remember, that's just by multiplying by the square root of 34 in the numerator and the denominator, and the square root of 34 times the square root of 34 is 34 squared, which is 34.
Yep.
Wait, why does it say ABA over there?
Oh, I don't know.
Is it supposed to be all B?
Yeah, it's supposed to be LB. Okay, so cosine of A, adjacent to A is 3. So 3 over 34, and I'll do this one out so we can see it. So square root of 34 times the square root of 34, right?
Mm-hmm.
And then 3 square root of 34. And this is always just going to come out to be what? Just the same, right? So 34. Oh.
After I did that one notes, are you going to do...
Yes, I'll do announcements. Okay, tangent of A. Opposite of A is?
5,
Adjacent is?
3.
So it's 5 thirds.
Mm-hmm.
Okay, sine of B. So it's going to be 3 over the square root of 34, which we got to rationalize all that down as 3 square root of 34 over 34. Well, cosine of B better be the same as the sine of A, right?
Mm-hmm.
So cosine of B is adjacent, so it's 5 over square root of 34, which is 5 square root of 34 over 34. And the tangent of B better be the reciprocal of the tangent of A, right? Well, adjacent to B is 5, opposite is 3. So I get 3 over 5. And are they the reciprocal?
Yep. Okay,
last one. What is the sine and cosine of the smallest angle? Uh-oh. How do I know the smallest angle?
Sides.
The sides. So it's the smallest side, right?
So 3.
So down here is my smallest angle, isn't it?
Yep.
And we're just going to call that angle theta.
Angle what?
Theta. Theta. So we have the sine of theta and the cosine of theta. So do those all on your own. I think you got it. Hopefully you found 3/5
Yep.
and 4/3. I will suggest to you that you write your fractions. 4/5.
Yeah.
Sorry, guys. I was worried about telling you this. I would suggest that you write your fractions up and down because we're going to be doing math with them, and we know that when we do it like this, we kind of mess it up.
Mm.
I only did it that way because my space. Okay, so that's all I got for today. Your